I'm back. Welcome to the Thursday night Minutes with Milo show. Broadcast, you say? Okay. I'll go with broadcast. Show. Oh, okay. There's that guy on the internet. Just making sure that I'm going out, and I am, which is cool because I didn't have a show Thanksgiving night, and I'm sorry I didn't announce that. I just was tied up in family things and eating turkey and dressing and all that kind of stuff. And I hope everybody had a good Thanksgiving. I did. And just slipped my mind to tell everybody not to tune in. I know there was hundreds of maybe thousands of people doing something else and they forgot, just like me. But anyway, I'm back tonight. And as many of you know, it's your Thursday, but it's my Friday. So I'm not working at work tomorrow, but I'm working doing work things. Have you noticed anything different? You probably noticed the big green halo stuck on me. Funny story. Not so funny story. Over Thanksgiving holiday, I was going to make some improvements to my system. Took me a whole day to try to do them and a whole day to fix it. So 2 whole days splat. But I got it back and excuse me. Jeez. I got it back, but in the process I had taken down my backdrop and I hadn't gotten around to putting it back up. Some time ago, I bought at I won't say a thrift store or something like that, but anyway, I bought a little green screen halo and brought it home, and it, of course, is not quite big enough to take up the whole screen. Apparently, this iPhone that I'm using for a camera has a super wide lens, and I didn't use it. And then that's when I was using boy, I wish I could remember what it was now, a different program to stream from, and they accepted green screens, and you could put different backgrounds behind you, and that's what I was going to do with it. It wasn't big enough, and then I started having problems and different things. I wouldn't mind getting back to it because I originally went to OBS Studio to try to overcome some of my internet issues because the other software didn't give you any feedback at all about what was going on or frames being dropped or anything like that. So I went to OBS, and it's a good program. I mean, it takes a little bit more to get used to set up, and there's lots of things that you could do with OBS Studio, but you've got probably to buy it. All right, and I don't buy it. I just do the free. I put up with the limitations, and I'm sorry. Let me scoot up. Oh, that's a little better. I'm a little more comfortable there. This thing is supposed to strap on the back of your chair, but when I strap it to the back of the chair, buddy, it's just everywhere. So what have I got? I got it strapped to me. That's right. And so now it's like a peacock tail. See? Look at that. Quack, 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 quack. But anyway, I'll get my normal backdrop put up again by next show, I hope. And all will be well. And I'll be free from this thing. I was going to do it tonight. Bring up, it's a pretty big backdrop just because the lens is so wide. So I had to put up 2 bifold doors behind me to hold the material. My heart goes out to the women in the audience. Wearing something that constrains you, not very comfortable, really. But anyway, tonight's show is about induction heat. And most commonly, I think you would see it in everyday life as a cooking surface. And so that's not what intrigued me. I've seen those things. Those things have been around years. And probably some of the things that I'm intrigued with have been around for a while. But like most things, the more they're around, the cheaper they get to buy. And we'll look at one of the things that I would like to have. Do I need it? No, probably not. But if you've looked at some of my other videos on the channel, you may realize I have some old cars. And every old car, every old machine, every old something has one thing in common, and that is stuck fasteners, bolts, screws, all kinds of stuff. And in the automotive world, especially in the rust belts, where they use salt to put on the roads, and the wet climates and things like that, rainwater, salt, ocean water, whatever it might be, corrodes things terrible. And you always get stuck bolts, and they always break off right at the flat surface, so you can't get anything on them. And there's ways to get around that. One of the ways I'd seen to get around that is a handheld device that you put over it, you turn it on, and miraculously it heats the bolt to like red hot temperature. That makes it expand, and that breaks down the stickiness between the rust and the metal. And then eventually you can get it out by heating it. And it's a quick, easy way. I do it with a welder most of the times, and works pretty good. Sometimes the thing you weld onto it to get a hold of it, to twist it, mostly a nut, breaks off. Look at I think that video's out there where I removed the exhaust studs from a LS motor, an exhaust bolt from an LS motor, engine block, head, and I weld on nuts. And then the nut gives you something to grab a hold of with a wrench or socket, but I think the big benefit is the heat that goes into the bolt when you heat it during the welding process, and that breaks it loose. So anyway, I thought that was interesting because now they're handheld, they're getting cheaper, and thought, induction heat's pretty cool, so let's see how it works. You don't touch it. The heating device never touches the bolts or the frying pan or any of that stuff. It's all done with electromagnets, and that's a simple version of how it works. And we will try to understand. I will try to understand, and hopefully it'll help you understand how this thing works. So let's get me shrunken down here a little bit. And yes, for all you visual learners out there, we're going to have a couple of videos. Yay! But we're going to read some stuff too. Anyway, now let's do this real quick. No, don't do that. I'm getting on my Google Voice so that if for some crazy reason somebody thinks they want to call in and talk to me, the number is down at the bottom of the screen. I don't know if that's left or right. It's my left, it might be your right. I don't know. But it's there. You can call that number, and if all works well, I'll answer the phone. And you can talk on the show. Alright, so wow, that's crazy big back there. How do we Okay, here we go. let's get over to Gemini. Gemini gives you the $10 version, and we'll look at the simple version also. All right, so let's scroll down a little bit because now I'm blocking it. So induction heating, 3 key principles according to Gemini. Alternating magnetic field. An induction heating device uses an induction coil connected to a high-frequency alternating current power source. The alternating current flows through the coil, generates a rapidly changing magnetic field around the coil. So, the way I understand electromagnetism, if you have a coil, circle a wire, and you hook a battery to it, now that's a battery, DC voltage, it runs around, and the electricity going around the coil makes it magnetized. And you wrap that around a nail, and now it takes that magnetism and transfers it into the nail, and you can actually pick up things with the nail that are magnetic just by simply attaching that wire, rolling around the nail, hooking it to like a 9-volt battery, and picking things up, which is cool as a kid's experiment. You can look at it online and do one yourself. But this one says it uses AC current. So the next key principle is eddy currents. When a conductive workpiece like a metal, bolt, or pan is placed within the alternating magnetic field, the changing field induces a voltage inside the workpiece. This phenomenon is based on Faraday's law of induction. This induced voltage causes localized electrical currents known as eddy currents to flow within the material of the workpiece. All right, so in my example, you wrap the wire around the nail and the nail becomes magnetic. In induction heating, the wire is wrapped in a coil but never really touches the nail. And then when you turn on the device, the eddy currents build up in the nail, and that causes it, based on the next principle, resistance, causes it to start to heat. So let's look at the third principle. Resistance and heat. The eddy currents encounter the material's natural electrical resistance as they flow. The resistance dissipates the electrical energy as heat, a process known as Joule's heating or resistance heating. This is the same principle that heats the element in a toaster. In simple terms, the coil creates an invisible magnetic field which forces currents, eddy currents, to flow in the metal object, and the metal's resistance to these currents causes it to heat up. So, if you ever looked inside almost any kind of coil heater, whether it's just a small heater that you sit down on the floor and plug it in, you turn the thermostat on, power starts to run through the coils. The resistance to that power makes the coil get hot, and that's where the heat is produced. So, with induction heating, it makes that heat into another piece of metal. Instead of the coil itself getting hot, the piece of metal that's caught in those magnetic fields starts to get hot. It never touches it, but that electromagnetic field that's created causes eddy currents in the nail, in my example, to start flowing through. The resistance of the nail itself, the metal, the steel, whatever the nail's made of, as long as it's magnetic, start to heat up, and that makes the nail hot, and it'll get to the point where, depending on the power of the device, red hot. And when I say red hot, not like molten, even though we will look at giant induction heaters that they use to melt steel and make it molten steel, which is super duper hot. But they use these devices, these handheld devices, to hold over a stuck bolt or a broke bolt, turn the device on, it creates that bolt to heat, and then you remove, turn the device off, take it away, and it helps unstick bolts. And that's the part that I like. So I don't know how long this has been around that you could heat bolts and get them unstuck. Probably a long time, and like I said, things are getting cheap. Let's see, what else has it got in there? Nothing really. So let's see if we can, this is a, let's see, what's this? Let's look at this. This isn't a video, but this is like I hope, a more reasonable with pictures explanation of how induction heat works. We read you the scientific. Why do I keep clicking on that? This is what makes it go up and down. All right, so here is the steel wire going around a steel pipe. Well, I'm sorry. They call it the induction coil. And it doesn't have to be made of steel, I guess. I don't know. But you can tell it never touches the steel pipe. All right? Induction heating systems with fundamentally higher viability are expected within the improvement and development of semiconductors. In addition, special coil shapes and designs provide expanded productivity. The point of these efforts is to work on the performance as well as the reliability of induction heating systems. Like I said, probably the most common induction heat device that everybody can see or could see are the hot plates. And they're used to heat things for cooking, mainly pots and pans and that kind of stuff. But the surface of the induction coil hot plate or heating plate, because the device itself doesn't get hot, but the pan that you set on it does get hot. So it's supposed to be a whole lot safer system to heating. Let's say you have a dorm room or a very small apartment, and you don't want to buy or can't have a stove or a traditional hot plate that the element itself gets red hot, and then you just sit on the pan on that. You can get an induction heating hot plate, heating plate. I call it a hot plate, but the device doesn't get hot. And it's much, much safer because you don't have the risk of igniting, things around you in a small apartment or dorm room. Induction heating. The currents, when induced in the material by electromagnetic action, is further utilized to heat it. It is known as induction heating. It is a contact-less electric heating strategy wherein the material will be heated without connecting to the supply. Basically, it's saying it doesn't have to touch the heating element. All right, let's get down here. Here's what I was interested in. Oop, where'd it go? Automotive. Induction heating is utilized for hardening or solidifying and tempering gears, shafts, and other car parts. Breaking bolts loose. Food and beverage, manufacturing. All right, get down here. Let's get some pictures. But it ain't no pictures. So let's watch a video. All right. So this video is apparently, not apparently, but is on YouTube. It is probably a review or an unboxing of Vivor's induction heating bolt removal 1100 watt 110 volt magnetic induction heater. So this is from Distractor Beam Reviews, November 28th, 2025. So this is recent.
Comes with a pretty nice case. And there we go. So we got our instructions. So the duty cycle is 2 minutes working, 5 minutes stop, then back to 2 minutes working. Got a couple of custom cable coils. So if you have an oddly shaped object, you can create your own coil to accommodate that. We got a very nice brown wrap on that cable as well. And then we got our pre-made coils. Very good wraps on those. We got 2 of them that are just under 1 inch, 2 of them that are about 1 3/4, and 2 that are about 1 1/8. So you can just match that up to whatever size bolt you got. And here is the heater. So we got our push button right there to get it started heating up. We got our threads.
All right, so this is what I was talking about. They're getting much smaller. Even though I've never owned one, I've seen some of the older devices, and they're pretty good size.
To lock in those coils. It does have an LED on the front so you can see what you're doing. And we got a 3-prong plug on the back. This is interesting. They actually gave us a key. This is for the case. In the event you want to lock that guy up, we can do that. And we've got our thumb bolts. So the idea is we're going to drop our coils in those holes. You're going to want to make sure that you see copper inside of there, and then we can lock that down. And we'll do the same thing for the other side, and that will be ready to go. So we got a bolt. We're going to use the good stuff on there. That is Loctite 290. Give that a good drowning, and a couple extra just for good measure. And we'll lock that guy down. I'll let that guy sit for 24 hours, and we'll come back to it. So when we plug it in, it does turn on. You can hear the fan pushing out the back. You want to keep that thing running. The main point of that is just to pull the heat out of the tool. So even after you do stop cooking, you want to keep this thing plugged in, keep that fan running for at least a couple of minutes. All I'm going to do is I'm going to take the end, I'm going to put that over the bolt, and I'm going to press and hold the button. See some smoke coming out of there.
He's a smoker.
That's actually really quick. Yeah. Starting to see a little red. And we are red. That is super fast.
All right. So you may not be able to see it. Let's see. Let me do that, change it. And let me back up just a little bit here.
Starting to see a little red.
So 44 seconds.
We are red.
That is super red hot. Now, can you see what he does with the tool when he's done with it? Okay. Look in that upper left-hand corner, up in here. There it is. Oh, what did you just do? Come on, man. Go back to full screen. Whoa. All right. That wasn't full screen before. Go back out of here. Let's go into theater mode. I think that was it. So let's see. All right. Where am I? He lays the tool down right here. This is the tool. So yeah, that's probably sticking out a little bit on the end, but see, he doesn't worry about where he puts it because the tool itself is not hot. But the nut on that bolt is red hot.
Yeah, pops right open. Yeah, I don't know why this one was so much faster than the ones I've dealt with before. Usually they take about a minute to cook up that hot, but this guy just baked that guy easy bake oven style. So overall, that is an awesome tool.
All right, so that was what I was interested in, is how to get those things red hot and, you know, get bolts unstuck, which I thought would be very good. So let's see if Gemini it has us a DIY video on induction heating and a heating circuit. So I asked Gemini if you could make your own induction heating tool, and they said, well, yes.
I recently found this rather interesting induction heater circuit for cheap on eBay. By simply adding a helical coil to its output terminal and applying 12 volts to its input terminal, I can place a metal object inside the coil and thus efficiently heat it up to a point where it glows red. And just like that, I can start cutting through things with a hot X-Acto knife, because sadly this is the kind of content way too many people enjoy watching. But how does this induction heating and the circuit actually work? Can we build one by ourselves? And which materials can be heated up? Let's find out.
So, one of the things I want to say here is these people that do this on YouTube, to me, they're either smarter than your average bear, or they're watching another YouTube video and then duplicating it on their own at home. Most of the time, they're smarter than the average bear, and they do these kind of things for fun. So, the do-it-yourself part, I mean, yeah, that would be interesting. But I hope he gets into how the heating works. I can't read that.
First off, I used my multimeter to track the circuit paths of the PCB in order to find out how the components are connected to one another. The reverse engineered circuit diagram only features a handful of.
Okay, so this dude's drawing out his own circuit. Or he's mapping the one he just traced through or just used. Either way, he's putting a lot of effort into this. And by the way, this video is put out by Great Scott with an exclamation point. Just so I'll give this this fella his due. And he's putting out a good video. Let me get that. There we go. All right. So this is who's putting out this video. Great Scott, exclamation point. He has 2.12 million subscribers. I think he's just a couple above me, but you know, I'm an up and coming struggler. All right. Let's proceed.
Of components, and is awfully similar to the circuits that I created for my DIY arc lighter projects. The only difference is that instead of a center tapped coil with one,
You know he does this a lot, because look at those whoop-de-whoop-de-whoop-de-whoop-de-whoop-de-whoop-des. He does that pretty good. And then, you know, whoop-de-whoop-de-whoop. You know, he uses a ruler for the straight lines, fine. But look at that penmanship. He's got good penmanship, and he's a lefty.
constant current source, this new circuit uses a more common coil without a tapped center, but with two constant current sources. This way, after powering the induction heater, a sine voltage and current is created at the output of the circuits, and thus the coil creates a changing sinusoidal magnetic field.
I think this dude's smarter than your average bear.
Now if I stick my finger inside the coil, the input current does not increase, and I feel nothing differently about my finger, except that the coil slowly heats up due to the flowing current. But if I take a metal conductor, form a loop with it, and place it inside the coil, we can measure a small voltage across it according to the law of electromagnetic induction. If we now close the loop, we basically created a short circuit, and thus a current will flow through the inductor, which is also noticeable by the increase of the input current. Since the equivalent circuit for this arrangement is just a resistor based on the dimensions of the conductor, we can assume that the generated heat is proportional to the resistance and the flowing current.
Wow. Okay. Let's skip to the visual fun part. What's he doing here? Let's try that.
But let's focus on the aluminum, and let's add a timer to the experiments. After 30 seconds inside the coil, the material reached a temperature of 37 degrees Celsius. So let's see whether brass can excel this temperature. This time the material increased the input current by 1 amp, and after 30 seconds reached a temperature of 48 degrees Celsius. That is around 10 degrees more than the aluminum piece, and actually not that surprising since brass possesses a higher resistance. Last but not least, we got iron, which after placing it inside the coil lowered the input voltage to such an extent that I had no choice but to put the two channels of my power supply in parallel and tried it again. But even with twice the current, it was not enough. So I was forced to only insert the tip of the material, which already increased the input current by 4 amps. After 30 seconds inside the coil, the tip of the iron easily reached a temperature of 106 degrees Celsius, which is quite a big difference compared to the other two. The reason for that is for one its higher resistance, but also its ferromagnetic characteristic, which means it can stick to a magnet.
Alright, so what I'm getting out of this, aluminum is not magnetic, and so it didn't heat up. I think he did brass, it's not magnetic, so it didn't really heat up either. But steel is magnetic, and so he just put the end of it in there because putting the whole steel bar in there overloaded or overpowered the little device he was trying to use, and it wouldn't heat it up. Too much material there. But if you just put the end of it in there, then there wasn't as much material, and it heated it almost 4 times? No, at least 3 times higher than what it did the brass or aluminum.
Magnets and can also be magnetized through magnetic fields. The process of magnetizing and demagnetizing.
Alright, I thought we were going to have some fun. Come on, man. Let's get into, oh, that's where he's building it. That's where he's building it. He's soldering it. He makes his own device. Let's see what it looks like.
We successfully created our own induction heater that can transfer enough energy to let metal glow reds. Now, if you have more questions about the utilized circuits, then definitely check out my arc lighter project and the previous hacked episode about the CCFL inverter. If you like this
If you like the video
episode and maybe learn something new,
then he has a Patreon account. You can go to his YouTube channel and figure out the Patreon. You can make donations. You can pay a subscription or something like that for Patreon. And if you're smarter than the average bear, or you want to be smarter than the average bear, then maybe you'll understand all this. Me, it told me you can buy a cheap, tiny, experimental induction coil heater off of eBay, put it together, which is, my speed, or you can maybe somewhere, I don't know, I skipped through a lot of it, maybe he puts a parts list out there on what parts he bought to make his own. You can build your own. Or you can do what I'm thinking about doing, is buy one. So let's see, let me get over here real quick and see. I got an itch, man. I got an itch. Got to scratch it. I don't know what you call them. Whoa, here we go. So let's see. No. Let's see, can you see this one? All right, so here's one. I don't like things that take so long, daggone load a lot of time to load. That's what I meant to say. Accept all. I'm not accepting all your stupid cookies. No, block. So this is a Northern tool. Block it. You don't need to know my stupid location. I'm in my studio. $525. That's pretty rich. Pretty rich. This is more my speed. Here we go. This is off of Amazon. This is a 1300 watt, 110 volt magnetic. Why are you doing that to me? Come on. Induction heater kit. Is this the Velvor? We could probably find one in Velvor. That was that one. This one's $280 on Amazon. It's a Harsire. Harsire? Harsire. That's a Harsire. So it looks like that one that guy did a review on. Right? They're probably all pretty close to being the same. Probably. So that one's, like I said, $180. Nice. And it might be well worth it. Okay. Amazon. Let's see what. This is Velvor induction coils. Where are they from? They're 35. Okay. Let's see if we can, what they are, if they have the device. They don't have the device listed. Repair tools. So they call it, instead of induction, it's magnetic induction tool. Okay. So that dude's 165. I don't know why one's cheaper, a little bit cheaper. Look at that. You can't see it. Yeah, you can. Those two devices look exactly the same. The pictures look exactly the same. But yet one's 165, 166, and one's 173. Why is that? Why is that? No, get out of my face over there. Let's look at the cheaper one. Alright, this looks a different color scheme, but it looks like what that other guy was advertising. Oh, this isn't for the US. How do I know that? Look at the picture of the plug-in. Can you see the plug-in? Maybe not. There's the plug-in. It's got that European style plug-in on it. Can you see it there? Yep. That's crazy. I guess those are in US dollars, 165 US dollars. That's not bad. That's not bad. All right, so one of the things we talked about was I've lost it now. There's induction countertops. We talked about that. All right, so here we go. This is one that melts metal. So let's see. Oh, go away, dude. Come on. Let's watch it on YouTube. Watch on YouTube. The reason I want to do that on YouTube.
Weaver's motto is tough tools at half the price, and now you can get a transit level at a really good discount today. This is a really nice transit level. It does come with a receiver, and as you can tell, when it gets close.
Boom. There we go. Okay. So this video on YouTube is by James Sword Engineering. James has 24,000 subscribers. Good for him. So if you like this video, do that. There we go. James Sword. Down there in the bottom. James Sword. If you like this, when we watch it, a little bit of it, you can tune in and see more all about it. Now this is
Induction furnace is a type of furnace in which currents induced in the metals by electromagnetic action are used to heat and melt the metals. In the induction furnace, a coil carrying alternating electric currents surrounds the container or chamber of metal. Eddy currents are induced in the metal charge, the circulation of these current producing extremely high temperature for melting the metal and for making alloy of exact composition. Induction furnaces are ideal for melting and alloying a wide variety of metals with minimum melt losses. It does not require any flame or gases that can be harmful to the environment to melt metals. However, little refining of the metal is possible. The advantage of the induction furnace is a clean, energy efficient, and well-controlled melting process compared to most other means of metal melting. Parts of induction furnace. The induction furnace consists basically of a crucible, inductor coil, shell, cooling system, and tilting mechanism. The crucible is formed from refractory material, which the furnace coil is lined with. This crucible holds the charged material and subsequently the melt. The inductor coil is a tubular copper coil with specific number of turns. An alternating current passes through it and magnetic flux is generated within the conductor. The magnetic flux generated produces eddy currents that enable the heating and melting process in the crucible. The shell is the outer part of the furnace. It houses the crucible and the inductor coil and
Alright. Let's watch melt metal, pour metal.
Melt the metal. The principle of induction heating is mainly based on two well-known phenomena: electromagnetic induction and Joule effect. When alternating currents flow in a conductor, it produces alternating magnetic flux. If conducting metal charge is placed within the flux path, EMF is induced in the material. The induced EMF develops eddy current within the material. The eddy current flowing through the electrical resistance of the metal charge produces high temperature used to heat the charge by Joule heating effects. In the case of non-magnetic material, the heat developed will be due to eddy current loss, whereas, in the case of magnetic material, the heat developed will be due to both eddy current loss and hysteresis loss. Once melted, the eddy current...
Right, so I think you get the idea. They make them huge and they melt metal and they pour it into molds. Right? So induction heating is basically heating things without touching it, using electromagnetic eddy currents built up in the material, and then that makes heat. So I would like to have one of those. Can I justify buying for a few stuck bolts? I don't know. I bought something similar, not really similar to this, plastic. There's lots of plastic in automotive interiors, exterior pieces, all kinds of things like that. And what I bought was kind of something similarly shaped to this, but you put thin wire in the two prongs, and a lot of times they're shaped like Z's, up and down, zigzags. And when you push the button, the current flows through the wire itself gets red hot, and then you slowly stick it into a piece of plastic that's broke. And then what it does is it melts into the plastic, you let go of the button, the plastic cools around the metal, which reinforces it. The heat kind of bonds the plastic together with this metal already in it, and then you take it loose from your little machine, your little wand, you snip off the ends that are sticking out, and it helps you repair plastic. And it works pretty good if the plastic is thicker. You know what I mean? It's got to be thicker than the wire. It just melts right through the plastic. So if you got pretty thick plastic, you can melt it in there. And I figured out after using it a few times that while the plastic was still hot, you could take a knife or a screwdriver, and when plastic melts, it bubbles up a little bit. And you could take that still hot plastic and push it back down into the crack again, and it would help bond the plastic together. And I've used that several times, and it has pretty good success. I used it for a couple of things that I was hoping that it would fix, that go under the car and help bring air into the radiator. You know, if you've ever seen those little chin spoilers or something, you scrub them along getting in and out of a parking lot or something like that, and a lot of times they'll break. And I had used those to put a bunch of those pieces up through there. And of course, you know, it did work for a while. Then you hit another dip in the road, or you hit coming in and out of a parking lot or something, you scrape them a few times, and it just breaks those pieces out. So it did work, but it doesn't work as well as I'd hoped it to work. But, you know, that's the way it goes. I like it. All right. So, oops, get back over here. So induction heating heats things by never touching it through use of, you know, eddy currents, oscillating magnetic current through the wire, the coil. So I hope you liked the video. It wasn't very lively, but I thought it was interesting because I think, you know, I won't say it's odd, it's different. Most people think if I'm going to heat something, especially metal, I use a torch or a welder, something, you know, that you contact and it, you know, makes things hot. But this, it doesn't even touch it. That's what I like. And it stays cool. The instrument stays cool. I like that part of it too. And being able to heat a nut or a bolt stuck to red hot in like a minute, and then being able to get it out. If you have 4 or 5 of those do, like I did on that LS engine, take a lot less time. I wouldn't waste nuts, welding wire, all that stuff. You just pull that thing out, plug it in, put it on there, heat it up for a minute, and then, you know, get it out. So anyway, if you liked the video, leave me a comment. If you thought it was a stupid video, leave me a comment. Tell me it was a stupid video. If you look through my other videos, you see something you like, you know, subscribe to the channel. Leave me a comment on those other videos. Like, subscribe, turn the little notification bell on, tell your family, friends, your enemies, your cohorts, your workmate, your at work husband, your at work wife. I don't know, somebody that you hated it or liked it. Maybe if they think you hated it, they might watch it. If he didn't like it, I'm bound to love it. Who knows? But anyway, I appreciate you tuning in. If you saw it live, great. If you didn't, it doesn't bother me. Watch them as many times as you want after they're uploaded and available for watching. So thank you. And I guess unless next Thursday's a holiday, something happens, I'll be here. All right. Appreciate you watching. And let's see if we can turn this off.